XPoSAT, India's first ever X-ray telescope. X-ray polarimeter satellite, XPoSAT, is a space observatory launched by the Indian Space Research Organisation (ISRO) on the 1st of January, 2024. There are only two X-ray polarimetry missions in the world. XPoSAT and NASA's IXP was launched in December 2021. Both missions aim to understand the extreme and mysterious phenomena in the universe, such as supernova remnants, black holes, neutron stars, and pulsars. Before we dive in, hit that like button if you're excited about this video, and please subscribe. Now, you might be thinking, X-rays? What's the big deal? Well, X-rays are a type of electromagnetic radiation that can penetrate through things that visible light can't. This makes them perfect for studying objects that are hidden from view, like black holes, neutron stars, and supernova remnants. So, what exactly is XPoSAT? XPoSAT has two payloads, Pollux and XSPECT. Imagine a superhero with two superpowers. Pollux measures how X-rays bend. It helps us learn more about where they come from, and XSPECT measures how X-rays change over time. It shows us the fast and slow changes of these space objects. Together, they are great tools. They help us understand the universe better. XPoSAT reveals the secrets of Cassiopeia A. XPoSAT took a closer look at Cassiopeia A, a supernova remnant left behind by a massive star that exploded 300 years ago. XPoSAT does not capture images, like the Webb telescope, but it does produce some visual representations of the X-ray sources it detects. This X-ray image shows an expanding shell of hot gas produced by the explosion. It is located about 11,000 light-years away from Earth in the constellation Cassiopeia. It is one of the brightest sources of radio waves and X-rays in the sky, and it reveals a lot of information about the elements that were produced in the star and ejected into space. This chart shows lines of different elements. These elements were produced by the nuclear fusion of lighter elements in the core of the star before it exploded as a supernova. The spectra are plotted as counts per second, CPS, versus energy, keV. The chart also shows the continuum emission, which is the background radiation from the hot gas in the supernova remnant. The chart helps us understand the chemical composition and physical conditions of Cassiopeia A. When the core of the star becomes mostly iron, it collapses under its own gravity, triggering a shock wave that rips apart the outer layers of the star. This shock wave also provides enough energy to fuse some of the iron into even heavier elements, such as cobalt, nickel, copper, zinc, and beyond. These elements are then ejected into space, along with the other elements that were produced in the core and the outer layers of the star. By analyzing these spectra, astronomers can learn about the origin and evolution of the elements in the universe. XPoSAT has a mission life of 5 years, and it will observe about 50 X-ray sources in the sky. Some of the sources are persistent, meaning they are always visible, and some are transient, meaning they appear and disappear unpredictably. XPoSAT will also monitor the X-ray sky for any new or unusual events, such as gamma-ray bursts, magnetar flares, or gravitational wave triggers. XPoSAT is a pioneering mission that will open a new window to explore the high-energy universe. It will help us understand the nature and origin of the X-ray sources, as well as test the theories of gravity and quantum physics in extreme environments. Don't forget to like, subscribe, and hit that notification bell to stay tuned for more cosmic updates.